Okay, the third page of the test. It says use long division to find the remainder, long division and give the remainder in fraction form. So we're going to do long division, 3x to the third plus 21x squared minus 6. We're dividing it by 3x squared minus 5. To do this with synthetic would be very challenging. You would have to factor this into two linear factors, not a quadratic factor. And it has to be x plus or minus something, x plus or minus something. So not easy to get this down to something where you could do synthetic division. I chose a problem here that would be not so difficult to do. 3x squared times what would make 3x to the third? All we'd have to multiply this by is another x, and it would become 3x to the third. Then I have to take x times the negative 5, which would be negative 5x. The saying is draw the line, change both of the signs, so now you can add. So we're going to add these two, and that comes out to be 0. If we add these two, we get 20. Ooh, this is x squareds, and this is x's. So I can't add these two. I have to keep them separate. So it's 21x squared plus 5x's, not like terms, so can't put them together, minus 6. Important to watch that you're adding like terms. So 3x squared times what makes 21x squared? Well, they both have the x squared, so I just have to multiply by 7. 7 times 3x squared is 21x squared. 7 times negative 5 is negative 35. Saying is draw the line, change the signs, and now we add like terms. These are like terms, they add up to be 0. This has got an x, this doesn't, so I can't add these together, so I have 5x. This is a constant, this is a constant. These two can be added together, so 35 minus 6 is 29. So my answer for this division problem is this divided by this is this, x plus 7, plus what I was dividing by underneath. I still have to divide it into this, into 5x plus 29 over what I was dividing by. And just to show you why this is the answer, if in a division problem, if I divide like, let's say 6 into 20, 6 times 20 goes 3, I get 18, subtract, I get 2, I put plus 2, 6, so that if I take 6 times 3, I get 18, and 6 times 2 over 6 is 2, so I get 18 plus 2, 20. Similarly here, if I took 3x squared minus 5 times my answer, 3x squared times x would be 3x to the third. 3x squared times 7 is 21x squared. 5 times x is minus 5x. Minus 5 times 7 is minus 35. So I've multiplied this times this. And this times this one, the numerator and denominator are going to cancel, and I'm going to get just plus 5x plus 29. And if I simplify this, I get 3x to the third plus 21x squared minus 5x plus 5x will cancel, and minus 35 plus 29 is minus 6. I get what I started with. So this is why the answer has to look like that. Write a degree 4, so it's got to be x to the 4th. It's got to have 4 terms. So if it's going to go through 2, it has to be x minus 2 to make this 2 be a 0. If it's going to go through minus 5, it has to be minus 5 plus 5 to be 0. To go through this, it has to be 2 plus 3i in for the x, and to make that be 0, it'd have to be minus 2 minus 3i. Put this in for the x, plus what we put here should make 0, because this is a 0. Now, if I were trying to factor a polynomial, I would divide this into the polynomial, divide that in, and then I would be left with a quadratic, and the quadratic is minus b over 2a plus or minus the square root part over 2a. And if this is negative, I'm going to get i's. And I'm going to get plus or minus the I part, not a change in the 2 part. So the other 0 has to be 2 minus 3i. Not changing the sign of both of them, just the part that's the plus or minus in the quadratic formula. Which means if I put this in for the x, I would have to subtract 2 plus 3i to make it be 0. So this is a polynomial 4th degree, x times x times x times x, degree 4, that has that 0, that 0, that 0, that plus that is 0, and that plus this is 0. That's 0. This one. If I just make the number line, I know that this, if I put 4 in here, this is 0. So 4 is, this has a 0, and it actually bounces there. And this 2 in here would make that 0, so it crosses at 2, and it actually does cross because it's not a bounce, so it crosses at 2, bounces at 4. This goes straight through at 2, bounces here, and it crosses at, straight through, because it's a single one, at minus 1. So at minus 1, it goes through, then it goes through, and then it bounces. So it could go this way, or it could go straight through, bounce, go that way. So I'm not sure which way, so I'm going to pick a number that's nice. Let's see. Zeros between these two. Let's see whether 0 it's negative or if it's positive. So I put 0 in here. Well, this is squared. So 4 minus 0 is 4 squared is positive. The square term is always going to be positive. If I put 0 into this, I get 2, which is positive. If I put 0 in here, I get 1, which is positive. So the height of the graph at 0 is positive. So it has to go through this way. It has to cross here, straight through at minus 1, and it come up and bounce and go down. So I didn't pull out the calculator. Now you can pull out the calculator and graph it, and you can see this also. And I asked when this is smaller than 0. Well, this part is above the line so it's greater than 0. Putting numbers in here like 0 gives us a positive number. We don't want that. We want to have this to be less than 0, which is this part is less than 0, and this part is less than 0, and this part's less than 0. Not there, though. That is 0. So I have one section, two sections, and three sections. So I got three pieces. Now the first piece, now when we solve these, we're looking for the x that makes this true. All these x's give a value for this whole thing of a negative number. So I'm going to say from negative infinity on the x up to this place, which was negative 1. At negative 1 at 0, we don't want to be equal to 0, so I do not include the negative 1. Negative 1 would make this graph be 0. And then at 2, it was 0, but just after that, it went down below. It was less than 0, so I have to start not at 2, but up to negative 2, clear to 4. No, plus 2 to plus 4. This graph is below 0, not including 4, because at 4 it was 0. And then after 4, and the rest of the way, it's all negative to positive infinity. So those are the three places where this graph is below 0. Below 0. Negative. Okay. Got to make a polynomial. It looks like this. So if it goes through minus 1, minus 2, minus 3, the factor must be x plus 3, because minus 3 plus 3 would be 0. It goes through this place, which I'm expecting you to estimate it. Some people said minus 1 1/3, that's fine. Or minus 1.3, that's fine, or something like that. So if I put in minus 1.3 or minus 1 1/3, I'm going to have to go plus 1 1/3, or 1.3. Minus 1.3 plus 1.3 would make 0, height of 0. This is at 1, so if I put in 1 for the x, it would have to be minus 1 to get 0, and it bounces, so that one has to be squared. And then it goes straight through at 1, 2, 3, 4. So if I put 4 in for the x, it would have to be minus 4 to make 0. Now, x times x times x times x times x, that's degree 5. And degree 5, negative numbers to the 5th, would always be down. This is up. So I know it has to be negative to turn it the right direction. And I'll just check that. I'll go to y equals, and I'll type in what we have here. Just without that minus, it's going to be x plus 3, close parenthesis, open parenthesis, x plus 1.3, close parenthesis, open parenthesis, x minus 1, close parenthesis, squared, and open parenthesis, x minus 4, close parenthesis, graph, and it, I've got some kind of strange graph here, so I'm going to go zoom 6. So it went up, down, up. Starts down. We want to start up, so we have to put a negative in front of this. So second, insert a negative, graph. Now it goes from down, up, down, down. So it came down, went up, down, up, down, down, up, down, up, down. That's the right direction, but it crosses someplace up here higher than 3. So I got to get it down to 3. Well, maybe that's like a third, so maybe I need to put 1/3 here, or 0.3, or point something. So let's go right there, and I'm going to insert, second delete, 1 divided by 3. And let's see now what it looks like. Okay, so that went through 1, 2, 3, 4, 5. And I want it to go through 3, so that wasn't enough. So I can do it maybe 1/5, which is 0.2 graph. And that looks like it's pretty close to 3. So 1/5, or 0.2, minus 0.2. Something close to that. X plus 3, x plus 1.3, x minus 1 squared, x minus 4. There'll be a lot of work to multiply this all out, but this is a polynomial in factored form, and so this is what I would use for my y, my f of x. Not this one. Or 1/5 would work, yes. 1/5 would work. Okay? All right.